All right, I just want to do these two problems in this video in 8.3, the Intro to Probability. The first one they're both card problems. The first one I'm going to do is 22, and then I will do 23. So 22 has you think about this problem in two different ways. One is multiplying independent events perspective, and the other is the one that I prefer, which is counting and using choose notation. So let's do what I think is the harder way first, because there's a chance for under or over counting. So the way I thought about this, okay, let's find the probability of getting a king, jack, and other card. So I have 52 cards. The probability of getting a king in that first card is 452. Now I just have 51 cards left, and the probability of getting a jack is 4 out of 51. And the probability of getting another card that's not a jack or a king, so I have to subtract out the 8 kings and jacks, would be 44. The problem that this is not the total probability here is the fact that I just assumed I was getting a king, a jack, and then another card in that order. But there's multiple ways I could arrive at this same hand. So I want to multiply this because I could add this to the probability of king, other card, jack. So the probability is actually greater because ordering doesn't matter, it just matters what's in my hand. So I have to multiply this probability of 452 times 451 times 44 over 50 times the number of ways those three cards could be dealt or arranged. So multiply that by 3 factorial. Because there's more ways to get the king, jack, and other card than just in that order. All right, well, let's think about it from a counting the possible ways perspective, or as I like to say, choose notation. So first, the denominator is your total sample space. So what's the possibility if I'm dealt 3 cards? So that would be 52, choose 3. How many 3-card hands could I have? And that, remember, choose notation takes into account that order doesn't matter. It's dividing out the order of those cards. And then I go to what I need. I need 1 king, so there are 4 kings. I just need one of them. There are 4 jacks. I just need one of them. And then there are 44 other cards, and I just need one of them. And that's it. So those are equivalent. I find doing the choose notation much easier. It does get a little more tricky when we go to, as we're going to see with 23 though. So 23 I'm going to do using choose notation, which was the second option in the previous problem. Okay, find the probability that you get 3 of a kind. That means 3 of the same rank, like 3 10s, 3 jacks, 3 aces, 3 5s. And we call king, jack, queen, ace, and 2 through 10. Those are ranks. So there's 13 ranks in a deck of cards. So find the probability that you get 3 of a kind if you're dealt 3 cards. Okay, so if I'm only dealt 3 cards, let's do our total possibilities for 3-card hands first. And the probability that I get 3 of a kind. All right, so let's count out how many 3 of a kinds I could have. Well, there's 13 different ranks, and I'm going to choose one of them for my 3 of a kind. And within that rank, there's 4 cards I have to choose from, and I just want to choose 3 of them. So that would be part A, 3 of a kind. Okay, let's do part B. Part B is if I'm dealt 4 cards, find the probability to get 3 of a kind. And notice I'm not including 4 of a kinds in my total. So the 4th card has to be unmatching. So 52, choose 3. And so I'm going to have, again, a 3 of a kind and then an unmatching card. So there's 13 ranks. I want to choose 1 for my 3 of a kind. And from that rank, I'm choosing 3 cards. And now from the 12 ranks left, I want to choose 1 more rank. And from that one more rank, I'm choosing one card. Okay, now part C. 5 cards, and we do not want to include 4 of a kinds or full houses. So in other words, with these 5 cards, I want 3 of a kind and 2 unmatched cards. So that's important. I'm not including full houses, which would be 3 of a kind and a pair. So I want, again, 3 of a kind and 2 unmatched cards. So I'm dealt 5 cards, so 52, choose 5 is my denominator. And then let's choose we're choosing one rank from the 13 ranks to be our 3 of a kind. And in those 4 cards, I'm choosing 3 of them. Now I need to choose 2 unmatched cards. So from the 12 remaining ranks, I'm going to choose 2 that are going to be unmatching. And within one, there's 4 cards and I choose 1. And with the other, there's 4 cards, I choose 1. All right. Part D. So what if I deal you 27 cards? What's the probability that you get 3 of a kind? Well, the probability is 1, or in terms of percent, 100%. And the reason is, think of the most extreme situations. Remember, 26 cards is half a deck. So say you had the most extreme situation where you had half the deck and it was all pairs. Well, if you get one more, it's going to be 3 of a kind. It has to be. So if you have more than half the deck, you've got to have a 3 of a kind somewhere. The chances are there's more than one. But because again, consider the most extreme case. If you have just 26 pairs, if you take one more, you're going to have one more card. You're going to have 1 3 of a kind. So there's no way you can't get a 3 of a kind with 27 cards. Okay, I hope that helped.